Okay, in this problem we want to find area bounded by this function, 2 square root of x, the x-axis, and then these two vertical lines, x equals 1 and x equals 4. It's really helpful to sketch a picture of the graph. So I'm going to actually start the graph at x equals 0, and we'll go out to 4. Oops. Okay, so 2 square root of x looks like this kind of shape. I'm just approximating here. So that is at 1, 2 times the square root of 1 is 2, so we're going to say that y value right there is 2. It doesn't really matter too much what the y values are. Actually, it doesn't matter at all what the y values are in this problem. But anyways, 2 square root of 4 is 2 times 2 is 4, so that's roughly 4. Now I'm going to go ahead and sketch in the vertical lines x equals 1. That's, let's do a different color. Let's do this. That's x equals 1 right there, and x equals 4 right here. So we want to find the area of this region above the x-axis of that. So when you integrate a function, you're finding the area under that function that's also above the x-axis, and we're going to go from x equals 1 to x equals 4. Those are called our limits of integration. So the area, or your setup, is the integral from 1 to 4 of 2 times the square root of x, and then we just put a dx, which doesn't really mean anything. Okay, sorry about that. So to integrate this, I'm going to pull the 2 out front, and then I'm first going to rewrite that square root of x as x to the 1/2 power. Okay, I haven't really done anything yet. But now I can anti-differentiate. 2 hangs out front. The integral of x to the half. So you add 1 to the exponent, and you do 1 over that number. A half plus 1 is 3/2 times x to the 3/2. And we're going to go from 1 to 4. Now you can put a parenthesis right here if you want to, but it really doesn't matter. So let's make some more room here. Now we plug in the upper limit. The upper limit minus the lower limit. So I'll go ahead and, no, actually I'm not going to put parentheses. Let's just go ahead and simplify before we plug in the upper and lower limits, because I don't like having little fractions within fractions. It's weird. So I have 2 times. 1 over 3/2 means 1 times the reciprocal of the denominator, so 1 times 2/3. X to the 3/2 from 1 to 4, and I'm going to go ahead and simplify one more step and multiply the 2 times 2 here. So 4/3 times x to the 3/2. Now that, you could just do this on your calculator, that's one option. I'm going to go ahead and rewrite it as a radical, because that way I can do the numbers 4 and 1 in my head. So x to the 3/2, I'm going to go ahead and write it as square root of x cubed, because that 1/2 power means square root, and then the cube part just stays up there. And we're going to take this from 1 to 4. Still haven't evaluated it yet, but now we can plug in. Now is a good time to do it. Plug in the 4 and the 1 and subtract. So it would be square root of 4 cubed minus 4/3 times the square root of 1 cubed. And I think you can get it from here to get your final answer.